Let me share a story. A young girl was very frustrated at her attempt to solve this problem. She knew the answer, but she couldn't get it the way the teacher wanted. So she asked, "Can I do it my way?" And the teacher said, "Sure, what's your way?" So the girl replied, "Well, if I simply take one off each of my numbers, I get this. And it's so much easier because there's no regrouping." Think about that for a moment. In this episode, I'm going to show you how to develop that thinking, and I'm going to give you a game to consolidate the idea. Before I look into that specific subtraction strategy, I need to review all three types of subtraction. And I'm going to use this equation for all three types. How would you calculate the answer to this equation? Because the numbers are messy, I suspect many teachers would place the tens above the tens and the ones above the ones to form an algorithm like this. Then they would follow the steps they learned as a child to take away the ones first and then the tens. And you know how that often ends. The first type of subtraction that students learn at school is called take from or take away. And that's where you have a portion and you're going to take something away from it. Now, take from or take away is implied with that equation I just showed you. And that's because students begin to read sentences like this. They might say 53 take away 28. So it's implying the idea of having a portion and taking something away. In real life, the story might go something like this. Kobe has $53 and spends $28. How much money does Kobe have left? But subtraction can also come in the form of unknown or missing addend. That's when you know the total and you know one part. You're trying to find out the missing part. So in a real world situation, it might mean the item I want to buy costs $53. I have $28. How much more do I need? That becomes the missing part. Now it sounds like an addition problem just because of the way I worded that. And you could indeed solve it using addition because you have $28. I could count on in some efficient steps to reach my total of 53. And lastly, subtraction can be a comparison between two totals. Suppose you have $53 and I have $28. How much more money do you have than me? Nothing is being taken away or removed. And I can use addition or subtraction to figure out what we call the difference. In this situation, the greater number becomes a total and the other number is interpreted as being the subtrahend. In all three types of subtraction, there is a total and a known part. You need to find out the missing part, which could be the amount left over, the missing addend, or the difference. Now, how can I apply this knowledge to this equation? Without a context, as I said before, it's easy to interpret this as being a takeaway problem. But if I think of subtraction as comparison, I can easily show two totals on a number line like this. 53 is one total and 28 is the other total. I need to figure out the difference that is between those two numbers. If I don't like using these messy numbers, then I can change each total while keeping the difference exactly the same. This becomes evident as I slide the jump one way or the other until I find two numbers I prefer to work with. Let's slide it to the right until we land on at least one number that is less messy. Now we have 55 and 30. Notice how the jump has not changed, which means the difference has remained constant. Is it easier to calculate 55, subtract 30 in your head? I think so. And we have done that simply by adding 2 to each number. But you might prefer to move the jump to the left like this. Is 50 subtract 25 easier to calculate in your head? Absolutely. And all we did was subtract 3 from each number. This strategy can also be applied to greater numbers. For example, Suppose you have 420 and you want to subtract 285. Those numbers look messy, which would have many students reaching for a calculator or many adults reaching for paper and pencil. But if you have a deep understanding of subtraction, you can easily apply that idea of constant difference. This is the difference between our two totals, which are 420 and 285. If I move the jump to the left, the difference remains the same, and now I have a new expression. Is 400 subtract 265 easier to solve in your head? I think it is. But others may prefer to make the subtrahend a nice round number by moving the difference in the other direction on the number line. Is 435 subtract 300 easier to figure out in your head? Absolutely. And the answer just jumps out at you. And what happened to that teacher that was using a subtraction algorithm with examples that involved multiples of 100? Well, it turns out she never used them again. She simply skipped or crossed over those examples from the textbooks she was using. It just doesn't make sense. You see, we spend so much time trying to get our young students to be able to round numbers. Why do we want them to round numbers to multiples of 10 or 100? It's because it's easier to work with those numbers in your head. It doesn't make sense to use an inefficient paper and pencil algorithm when you already have nice round numbers. So this is what I want you to do. 1, learn the lesson that teacher learned. Look at the numbers. What method or strategy do they lend themselves to? And 2, remember that there are 3 distinct types of subtraction, and they all appear in modern elementary or primary school standards. So teaching students all 3 will give them a deeper understanding of subtraction and better help them or equip them to solve subtraction problems. And 3, using a number line is a powerful way to model that strategy for your child or your students. And using the game in the link is a great way to consolidate that thinking. And finally, I would appreciate your support by giving us a thumbs up or subscribing today so you never miss another learning episode with me. See you next time.